there are some prerequisites that need to be installed before starting the course.
Hey, I hope you're having a good day. My videos will always be free, no paywalls. And with that, let's begin.
Okay, so there are some prerequisites that need to be installed before starting the course. So first of all, we need the latest version of Python. So click on this download button and you have an installer downloaded, and go to the installer. After opening it, give custom install, give next, and make sure add Python to environment variables is selected and give install. After installing Python, we have to install Jupyter Labs. So go to the official site of Jupyter, links in description, and click on install. And here you have a bunch of codes that need to be run on the command terminal. So let's take this first code and go to a command prompt. No need administrator permissions, just a simple command prompt, and click enter. It's gonna download all the dependencies and copy this code. And every time you want to open Jupyter Labs, just type Jupyter Lab and enter, and it will automatically open it in your browser. So there you have it, Jupyter Labs. But when you open it, this is the default view. But if you want a dark theme in here, go to settings, theme, and choose Jupyter Dark. And there you have it. So let's open our new notebook, or where we will be entering the commands and getting the outputs. So click on this and let's get started with the basics. So let's get started with the simple basics of Python. And these are some definitions of Python. You can read through them. And we'll get started with the super simple basics. First comes the print statement. So before you start, if you want to close brackets automatically, make sure this option is selected right here. And so we type the word print and open brackets. We have the option enabled. You'll see it close automatically. And then put single quotes or double quotes and type in anything you want, and shift plus enter, or you can just click this button and it's going to take the inputs from here and this will be the output. Next, we have the assignment operator. What does the assignment operator do? Assignment operator assigns a value to a variable. So we can take a variable as anything, any name, any letter. So let's take A is equal to 10. So what this does is it assigns A the value of 10 and shift enter. And so if we print the value of A, we get 10 because A is assigned the value of 10. But if we can also reassign the value of A, and if we print the value of A now, we get 15. Talking about the arithmetic operators, let's take two variables. So we'll also have B is equal to 10 and C is equal to 15. Run them. And after that, we'll start with addition operator. In Jupyter Lab, you don't always have to print it. If it's only one line or the last line is what you want to print, you can directly type in the code. It gives you the answer 15 plus 10, 25. Or you can even type it as print A plus B. This is mostly recommended. You get 25 here. In the same way, you can do A minus B, A asterisk B, which is multiplication, A divided by B. This is a decimal because we divided A 15 by 10. So we get a decimal answer. And we have these three are important and must be noted. Percentage sign here returns you the reminder. So if it's a A percentage B, we get the reminder 5. Because when we divide 15 by 10, we get a reminder of 5 because 10 ones are 10 and the reminder is 5. So there is no more number, so that's the reminder. This refers to exponent. So if we type A star star B, we'll get exponential powers. So it's gonna do 15 raised to the power 10. And last we have A divided by B. This is referred to as flooring. So what does flooring do? It floors the variable. Here we go 1.5. Here it's rounded up. So it rounds off the value that is there in division. That means it takes away the decimal point. So coming on to comparison operators. These often return a Boolean value. There are two Boolean values, true or false. So if we type A greater than B, we get true. And if we type A less than B, we get false. Because A is 15 greater than 10, which is obviously true. In the same way, A equals B checks if both of them are equivalent, which is not. And if A not equal to, this will give us true because A is not equal to B. And we can also check with greater than equal to or less than equal to. In this case, is A greater than or equal to B? Yes. Because A is 15 and B is 10, which is greater. But if A is also A is equal to 10 and A greater than equal to B, it returns true because A is equal to B. This takes in two conditions. Now, let's move on to another important basic. Strings. In this chapter, we will be learning about many string operations and many string manipulation methods. So it's going to be covering most of the string concepts. So let's get started. Strings can be written in a single quote, a double quote, or even triple quote. So let's define a string, or let's give an example of string is equal to a single quoted one, hello world, and we have to print the string there. The string is printed. We can also define the string in double quotes. String 1 is equal to double quotes I, string 1 there. And we can also have triple quotes, which is multi-line string. So string 2 is equal to 1, 2, 3, and I, hello, bye. String 2, there. It's this slash and refers to new line. So it's in this format, next line, next line, next line. But Jupyter Lab just puts it in this way. So let's get started with some of the basics of strings. First, we'll get started with indexing. So indexing is something which returns a specific element from a string. If we consider element or the string called hello, hello will be taken into HELO. So indexing always starts from a 0 not 1. So it goes like 0, 1, 2, 3, 4. And if I want this L, I'll be indexing it as 2. If I want this H, it's not going to be 1, it's going to be a 0. So let's consider our string A is equal to hello. And here, we will type A of, in square brackets, we'll specify the index. So if we give 3, it's going to take 0, 1, 2, 3, this L. We give A of 0, it'll give us H. There is also another indexing called negative indexing, which starts from -1, not 0, -1, -2, -3, -4, -5. So it goes backwards. So if we type A of -2, we get this L, or A of -1 gives us O. Next, we'll go with dot index. Dot index gives us the first occurrence of a specified value in a string. So let's take the same example, hello, and we are going to do a dot index of H. H is a string, so we will have to place it in single quotes, double quotes, and type in H. It's going to return the index of H. Suppose we give a dot index of O. It's going to give 4. And a dot index of L. It's going to give us 2. Because not 3, because it will give us the first occurrence, 0, 1, 2. L occurs at 2. So if you have 5 more L's here, it'll still give you 2 because it will only take the first occurrence. Now let's go on to slicing. Slicing is another important thing. This time let's take another example. We will take hello Sapien. So hello Sapien has a space here. That doesn't matter. So the indexing is 0, 1, 2, 3, 4. A space is also an index. So 5, 6, 7, 8, 9, 10, 11. So the thing to be noted here is if we take an example of P is equal to hello space Sapien, and we print B here, it's hello sapien. But if we give slicing, for slicing, we use semicolons. There will be an index here and an index here, the 2 indexes. Or if we give a colon, just a colon, it's going to print the whole thing. Suppose we want it from E, from the letter E to the rest of it. E has an index of 1. Is 2, and it's gonna print from 1 till the end. So if we take the other way around, or we give is to 5, notice that it starts from 0, 1, 2, 3, 4. Whatever comes here, if you mention something here, whatever comes at the end, this index won't be printed. So the space, which is 5, won't be printed. In the same way, if I give 6. No, so my bad. If I give a 6 here, it's going to go only till the space. S won't be printed. In the same way, we can give 1 or 4 is to 8. Notice P, which has an index of 8, won't be printed. So it's going to be 4, 5, 6, 7. Now in slicing, there is also something called steps, which can be given using another separate semicolon. So if we take this thing and we give b of colon, the default step is 1. If we give it as 2 right here, it's going to print every odd digit. So it's going to print H, L, O, S, P, E. And we can also add our own letters here. So if we take the index 2, this will go from the index 2 till the end. So it's going to start from the index 2, L, O, S, P, E. We can increase the step size to 3 and we get a different result as it takes a jump of 3. And after that, in slicing there, we can also use negative index. So we can use colon it starts from minus 4 is to minus 1. We get pi because minus 1 won't be included in here. It starts from E, then this is minus 4, minus 4, minus 2, minus 4, minus 3, minus 2. After that, we also can use step sizes for this. So if minus 4 is to minus 1 is to 2, which skips with the step size of 2. And there are 2 important or interesting cases in here, which is if we give it in reverse order. If we give 4 is to 1, it's not going to print anything. Or if we even give minus 1 is to minus 5, it won't give you a result. This is because you can't travel back. It's only this way. Slicing only works one way. Slicing doesn't go the other way.
I missed the len function, so let's learn what the len function does. So a len function, it returns you the number of items in the list. Here we are doing for strings, so it returns the number of characters in a string, right? If you have apple, if you type len of A, it gives you 5 because APPLE, there are 5 words. In other words, it's called 5 characters, so Apple gives you the length of 5. Unlike indexing, Apple, its len function, it starts from 1, 2, 3. It's similar to counting the number of letters in the word. Also, even if there are numbers, it still returns you the length of this because this is not considered as an integer. Since there are single quotes around it, it's considered a string. A space is also considered a character. If I have 2 spaces, you can see it's 4. Special symbols like plus, division, all symbols, etc. are considered as the len function. So even a hashtag gives you an increment in the len function. So that's what the len function does.
Okay, so let's go to the next topic. This will be dealing with strips and strings. Strips and strings, these are very important and super useful because it allows you to remove the white spaces. So I'm going to type something like, oh, yes, something like A is equal to space, 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 DOT space, 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 and run it. So A will be dog with space at both sides. So if you want to remove the space, we'll have to type A dot strip. But know the thing here is that if you call A again, it's not going to remove the white spaces because this doesn't directly change the value of A. Rather, it just is a view or a copy. So if you want to manipulate the value of A directly in here, you will have to assign it again. So A is reassigned to a.strip. And if we run this and run this again, a's value has been changed. So writing just a.strip doesn't change it. You'll have to reassign it, or you can even reassign it to another variable and print b. Now, lstrip and rstrip is to remove the stripping from, let's take on this one, and this can be used to remove strips from the left side or the right side. So if we type c is equal to a.lstrip, we get it stripped from the left side. But if we type d is equal to a.rstrip, it will be stripped from the left side. That is super important. And there is another use case of this strip function, which can also be used in left strip and the right strip. If suppose we have a string with dash 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 calendar, you might have seen this somewhere, and this is the output. And if we type a.strip, it still gives you the same thing, because default or by default, strip function only removes white spaces. So what you will have to do for that is you will have to enter the thing you want to strip in here. You want to strip the dashed lines. So there you have it. Calendar is stripped from the dashed lines. And we can also give it as a.rstrip of dash. And suppose we can also, after this, let's assign it another variable called v, and this is going to be v. We can also v.rstrip even a character like r. Calendar, r has been stripped from the right side. If we give a character which is not there, it just doesn't do anything and returns the value as it is. Another point to note is that this is case sensitive. So if we type v.rstrip of r, it removes r. But if we type in a capital R, it doesn't remove it. So now we'll start with something called fstrings, but before that, let's learn something called the input function. What does the input function do? Input function, it must be noted that it will return a string. So if we give something like, what is your age? And you type in 70, it's going to return a string. This doesn't assign to something, so let's assign it to variable a. Now give here 70, and you can print a and you get not 70, but this is a string. We'll talk about conversions later, or let's just do it now. So if you want to convert something into another variable type, you just have to type int. Suppose I want to convert this string to an integer, just type int a. And we can assign it back or to a new variable. So we can check this type by using type of a, which is integer. But here, if we will take this example again and take b, we'll type in for type of b, which is a string. So if you want to convert something to a string, str of a, and this type of a is int, because this doesn't override it. And if we assign back to a and this, you get string. But there is also something else to be noted, that is, you can't assign, you can't convert a string to an integer if it is not an integer. Suppose if the string is I, and if you type int of b, we get a value error because I is not a number of the base 10, so it can't be converted to an integer. If you take b is equal to 9, int b, you can get it. We can also use binary, which can't be converted like this, so you will have to convert it to an integer first and convert it to binary. Binary always returns it as 0b at the first and this number 9 and 1001. Okay, apart from this, some of the other ones include complex of b, which returns you a complex number, which is a number with its imaginary part. And we also have something called float, which converts it to a decimal format. So this is float. Now that we have learned about typecasting, this refers to typecasting, converting to int, binary, complex, float. There are more which we'll learn in the later lessons. Let's get back onto track and start with strings. So if we type the name as human, or no, let's take human name, something like Bob, not mine. Age is 70. And then we are going to print an S string. For S strings, we have the string with an F. So F must be mentioned before the quotes. It can even be double quotes, so let's go with a single quote. My name is. We have curly braces, name. And I am 8 years old. So what it does is this two are variables. So it takes Bob and put it here. It takes age and put it here. And we're printing it. Let's print it. And you get my name is Bob and I'm 70 years old. We can also do something else with this. Suppose we give 10 and B is 20. F string 2 is equal to F A plus, you can just give it as plus, B is A plus B. You can directly do the operations, but make sure these are in curly braces. F string 2, which gets 10 plus 2 is 30. Or you can even, let me show you something else about the print statement. We can do sum is, comma, A plus B. Leave a space here. Sum is 30, or don't leave a space, it will be single spaced. Okay, so we are done with this portion of the slide. Let's go to the next one, which has title case, lowercase, uppercase, capitalized, and swap case. This is interesting. Let's get on with it. So let's type the name as Bob Sanders. And so the name is assigned as Bob Sanders. We'll start with the first one. Name dot title. It must be noted that this doesn't manipulate this. So Bob Sanders, each and every letter. So if I just give it something like S, it's going to capitalize each word. Each word's starting letter will be capitalized. So note that this doesn't affect the original. In the same way, we have name dot upper, which makes everything in uppercase and name dot lower converted all to lower cases and name dot capitalize. This makes the starting of This makes the starting of each sentence a capital letter. So only Bob will be capital. And swapcase. Swapcase is interesting to note. Let's show you what it will do. It's going to swap the capital letters with small letters and the small letters with the capital letters. So swap case and B becomes small. Rest of it is in capital letters. Great, we're done with another one. Now we have some operations that return you something called Booleans. All of these here return Booleans. So let's start with them. Okay, so since all of these return a Boolean value, we'll do them one by one. And so let's take a name called Jacob, and we'll type name dot is alpha. ALPHA, which is true. But if I give something like Jacob 1, it's not going to give true because 1 is not an alphabet. Now we'll take for the case of isDigit. So digit is equal to 1, 2, 3. And if I give name dot isDigit, it will give you false. And if I also give digit dot isDigit, it gives true because all are numbers. But even if I have a small white space, it will give you false because the last character here is not a digit. Is space only returns true if everything is a space. So let's give it like this, and a dot is space, which gives true. If I remove the space, put an empty string, I'll give you false. If I give a with a space, it will give you false. Only spaces will give you true. Is upper text if all the characters are uppercase. Take B is equal to up and B dot is upper. By the way, you can code with me. It's better that way. It's false, and if I give it as up, it gives you true. And is lower is directly the opposite of this. If you give AP and B dot is lower, give you false because P is capped, and it gives you true. But what if you give here 1? Is it? It gives you true. P, it gives you false. It only checks for alphabetic characters and if it is lowercase. So even if I give store and it gives you true. What about the space? A true. If all the alphabetic characters are in lowercase, then it's pretty fine. We're all with this lesson. Let's go to the next one. So let's start with is numeric. This is similar to isDigit, but there are some differences. So if we type something like 1, 2, 3 is numeric, we get it as true, but in the same way, it will show false for anything else. It will show false, but the difference is that there are certain things called Unicode characters, like Roman numerals, but something like this wouldn't give you a positive one because they do not have Roman numerals are represented. So we'll go to this side and copy this Roman numeral, and then we will paste it here. This is a Unicode Roman numeral character, and we get here true. But in the case of if digit, it gives you false. So this has more scope compared to this, but they work the same for when it comes to numbers and letters. And if you give an F here, it's going to give false. If you give an F here, it will give you false. Startswith gives you a Boolean value, either true or false, if it starts with the thing you're going to specify. So let's consider the name called Martin. And let's get the capitals and name dot starts with. You obviously have to give an argument here. So if I give here M, I'll give it false because it is case sensitive. And if I give here M, I'll give it true. AR true because it starts with MAR. But if I give MER, it gives you false. In the same way, it works with ends with. If I give here ends with N, true. And I? No, it doesn't work that way. It works in the reverse, right? So ends with IN? Yes, it's true. You can even have Martin Rogers and type in RS and it gives you true. What about a space? If we type N, it's a false. And with space, it's a true. Now let's start with Expandtabs. This replaces the tabs in a string with spaces or the number of spaces we specify. So let's take an example like A or string is equal to I/T. /T is an escape sequence. Like /n, as we saw earlier, refers in multi-line string. It refers to a new line. So let me give you a different I/n I. This, when we type string, it'll give you like this. But you need a print statement. Look at it. It takes it as an escape sequence, not as a literal string, but an escape sequence. So even if you type /n/n I, it makes it enter two lines. So in the same way, we will deal with /t and I. What it does, but if you just give it a string, you get this. So it has 8 spaces over here. And if you want to print string dot expand tab here, you can specify the number of tabs or the number of space. What space do you want here? If you give it empty, it will give you the same as before. But if I give here 20, there will be 20 spaces in here. Or I can even do it like /t by here, 20 spaces between each t. Now coming to partition. Partition is used to separate a string into 3 parts. Okay, so we will start with a simple example like a string 2, which is going to be Casefold is... No, let's give something else. So water is formless. If we type print string2 dot partition, we obviously need an argument because it takes in a single argument and we have given 0. The arguments are mostly written inside this curly braces. So what is the string by which, or the part of the thing by which we are separating? We'll give s. Okay, this is taking for this, but let me give it as 1. Okay, my bad. 2. So it takes is and takes formless water. So it takes is as 1 and whatever is to the side of it, it's taken as another string, and whatever is to this side of it, it's taken as another string. We can check its type, and the type is a tuple. We'll be discussing about tuples later. Just know that it's a type in Python, so it's immutable, and we will be dealing with it more in the future lessons. I mean, the coming ones. So also notice that this space is in this spot and this space is in this spot. So what if we give something that doesn't exist? It's going to give you this whole thing as one tuple or one part of a tuple with 2 empty strings. Now we're done with this. Let's move on to the next one. Okay, now we'll start with remove prefix and remove suffix. So remove prefix is used to remove from the back or from the start, and remove suffix is from the end. So let's take a text called "This is my land." And here is the text. So if we want to remove the prefix, remove prefix of, we need an argument here. So we need to give something like this is my land. So this has been removed. Let's take another example like $100. This is a useful case. And so we can remove the dollar symbol. If we give something that is not there, it returns you the same string. So we can also use text.remove suffix of 00, and the zeros from the end have been removed. But there is also a thing to note that if you give for remove suffix $, it doesn't remove because it starts from the end and it should be similar. So 01 also doesn't do anything. 10 doesn't do anything. And 100, it does. It does remove because the last 3 are matching. So it removes the suffix. Now we will take center. So what does center do? Let's take an example text which is sun sets in the west. And if we take text dot center, it needs exactly one argument. This one here is optional because the default fill character will be space, white space. So if we give like this and text.center, we get the same thing. Why? Why? Because this number here, if this indexing, let's check the length of text, which is 20. This is less than 20. So 10 is less than 20, so it doesn't do anything. If you have something like 22, it gives one white space here. If it's something like 23, it gives one here, two here, but only one here. 24 gives two on each side. We can also add a fill character. So this length right now, if we check length of this, it is 24. So that is what centering does, and any length above this, since it's 24, so 4 asterisks will be added dividing these two, at the prefix 2, at the suffix 2. Split is another interesting thing. So what split does is text.split. It can take an argument, but that is optional. So what it does is it gives you a list. Check the type. We will learn about lists later, but just note that this gives you a list. So suppose if you're given a string and you want to convert it to a list instead of adding list. So how you add a list is you type the same thing, A is equal to B, Control V, and you get this. Now A is a list. This is how we define a list. We'll talk about it later. So instead of doing that, typing each open brackets, close quotes, open quotes, that, close quotes, comma. Instead of doing this, you can just type in a string and just type dot split, converts it to a list. So another thing you can do is you can specify a word. So this works same like partitioning, but the difference is in the West and in the North, humans live. In the South, bears live. The difference is now if we split it, it's going to split it. This is not, what do you say, a new line. It's just that there is no space, so it's just designed this way. So it's not new line, by the way, but it's going to split it based on this. So every in, based on this in, as you can see, in is not mentioned here. It is going to give sunsets as one part element in a list. The West and is another one. So if I give A in B in C and run this line, it's going to give A, B, C. You can also give another letter like A. It's fine. Anything, any string, it's based on your string. So that is split. Split is super important, so make sure you note that. Now let's start with replace. Replace is used to change the string. So if I have a string called hey boy, now the boy becomes a man. So we will have to replace boy with man. So instead of just changing this to man, what we will do is text dot replace. It takes in two arguments, the old one and the new one. So first we will have to give the old one, which is boy, and the new one would be man. It shows you hey man. Now let's go on to the join iterable. This actually, it takes in a list and converts it to a string, but we haven't dealt with the list. So let me give you a simple example. So how we write a list is A This is a list. The name of the list is A with brackets. We will do this later, but just for this topic, we are taking a list I, comma, your second variable, I, Bob. And this is a list. So let's give it the type of A. It is a list. So we are going to have to put this dot join the list name hi Bob. If you give a space here, you'll have hi Bob. Let's also give Junior hi Bob Junior. You give something like star hi star, it's going to be replaced. So without space, with the space, this looks good. And coming on to this one, join reverse. This is what we need to use to join foreign strings. So there are two ways to reverse a string, which you can learn right now. This is my property, is a variable called text. And now, with the space, join. Since we are reversing it, space won't be necessary. We are gonna use the reverse keyword, and then we will specify the string. So join reversed. So what happens is everything gets reversed. This is one way of doing it. Put it with the space, it's going to give space between every single thing. So this space will have two spaces. HI will be spaced and it will have a reversed notation. Another way to reverse the string is text. We can use step count. : step will be -1. We have heard that step of 2 will give you chunks of 2, but if they give -1, it will print it in exact same reversed order. This right here is really useful because if you have something like mom, you can use it for checking palindromes. So let's take this called mom is equal to mom. So if you have something like this, so a variable is given for you saying check if this is a palindrome. So all you have to use is check if A is equal to A of is to -1. If this is true, that means it's a palindrome. We will use this with the if condition later. So now we will start with the find. So find returns you the first index or the lowest index of the substring. And to be noted is that if it is not present, if the string you're finding is not present, it will give you -1. So let's take a sentence, which is Mark and Rob and Bob. For the example, there are two ands here. So we will take send.find and it returns you 0, 1, 2, 3, 4, 5. This index, but not this one because this is the first occurring instance. But if we give Andy, it will give you -1 because it doesn't exist. So it returns the first index and only the first occurrence. So if there are multiple ands, it won't give you indexes of each one separately. Count. Count is used to count the number of occurrences. We'll take the same example and let's give count of its needs an argument. So count is 2 because there are 2 ands. Or if you give something like A, it's going to count each A. Let's take B. B occurs 3 times in this example. If it's N, it comes 2 times. So that's how count is used. It gives you the count. But if it's something that is not there, the count is 0. And we are done with this. Let's move on to the next one. So this is the last of strings, the last 5 topics in strings. And we will be starting with the next topic. So let's complete these. So let's start with the first one, strings. We have done this, so just a refresher. So we have 1, 2, 3, 4, 5. We can directly pass it, or if we have a variable called 45 into star 456 and str of s. It's going to return this result in string, but if you also give s, it's 2050. So you can also have 8 star 8 star 8, and it'll give you a string. So that is the string function. So coming on to format. Format is super important, and there are 2 ways in which, more than 2 ways actually, in which we can put the format. So we need to consider a string, which is something like my name is, and I am, let's take something else. My favorite food is, and I eat it times a week. So we give here dot format, and here we can specify it should be equal to the number of curly braces we have given here. So we will give first an argumentative in args format. So my favorite food is cake, and I eat it 2 times, and print the string. My favorite food is cake, and I eat it 2 times a week. And so we can also give quarks. Quarks are arguments with name parameters. So food and number. So here we give food is equal to number is equal to. And there you have it, cake 2 times. But if you give it like this, without even 1 parameter specified, you get an error. So make sure that the named arguments are here. We can also do something like 2, comma, this. But since it has quarks, this is a quark, this is an arc, it is both, you get it properly. But what if there is something like 2, 3? 2, 3. But what if you want this one here, this one here? Instead of 23, you want 32. So that's where indexing comes in. So according to this, you should also note that the args must come first. See, the args must come first. So it's going to be 2, 3. Good. And here you can give positional arguments. So 2 can be given 0 here and 1 here. So it becomes 32 times. So that is how you use formatting. So you can also use the strings before, and this is another way in which you can use formatting. So formatting, in summary, has args, which is a named parameter, and args, which doesn't have a name, but you can specify them with indexes, and all args must be given a name in the curly braces. This name must be here, or if I just remove this name, you will get an error, a value error, because this parameter is not implemented. Or if I don't use it, you can still have it just for the keepsake, but you can't leave an extra parameter out. Another interesting thing is you can even repeat your indices. Let me give here name, and okay, so this was food. And so if we run this, we get 22 times. In the same way, food and food. I eat cake and cake, and I eat it 22 times a week. Now, coming to Casefold, we can see that it's similar to dot lower, but there are some differences. So let's give a string called hello, Bob. Boba. Hello, Boba T. Okay, let's give capital letters and string dot case fold. It gives you in lower cases, and they mostly work similar, but you'll know the difference, which is mostly not used. Let's just consider another string called strop. This is a special symbol, and in German notation, it is called SS, so it is straws. That's what it's spelled like. But if I go here and type another dot lower, it's a beta symbol, I guess, and you get it as straw. If I give another dot case fold, it's going to give straws. So this is different. It's more complex and more powerful than the lowercase. So this is mostly not used in a common case, but that's the difference. So let's start with the last two topics. So this refers to make translation, or it creates a table, and this is used to implement the table. So let's take an example called a table. This is the variable name and str.maketrans. Here we need two strings. One is for mapping and one will be mapped. And if you print the table, we get this. So this is just a Unicode representation. What it really means is that A is mapped to 1, B becomes 2, and C becomes 3. And to implement this table, we use translate. So if there is a text called ABC eats apple, and if we print text dot translate, here we will have to specify the mapping table and run it. We get A changed to 1, B becomes 2, C becomes 3, and so on for every one of them. And we can also have different variable mappings. For example, if you want to change a hashtag to $, you can do it. For example, here, $ABC. That is an interesting case. So with this, we have completed our strings.